Hello, everyone. We're happy to see all of you here today. Firstly, let us check the sound and picture quality. Please tell us in the comments box if you can hear us well and see the presentation. Please type something like plus. Thank you, Yunus. Great, let's begin. Let me introduce myself. My name is Alina Zharikova, and I am a business development manager of Ruler Technologies. And today I will be moderating the webinar. Next to me is sitting Philips Tumshajs, our today's speaker and software engineer. We would like to begin with the congratulations on the upcoming Women's Day. The 8th of March is an important date in Latvia and worldwide. And taking this opportunity, Philips would like to congratulate all ladies who are listening to us today.
Hello everyone. Tomorrow is the International Women's Day, and I wish all the ladies luck, patience, and of course inspiration. I hope you'll have great holidays.
Thank you, Philips. While we're still waiting for some people to join us, let me tell you a few words about Ruler Technologies. Ruler is a leading-edge European manufacturer of test and measurement instruments. We implement customized solutions for automotive, aerospace, research, and other industries. The company is headquartered in Riga, Latvia. Ruler mainly manufactures vibration control and data acquisition systems, power amplifiers, and softwares. By the way, there are 3 types of software that we manufacture: TestUp for vibration control, SignalUp for signal analysis, and calibration software for calibration. Our today's topic is mastering multi-channel control for aerospace and defense, and we are going to extend your knowledge in this area. Philips, could you tell us why did you decide to choose multi-channel control as a topic of March webinar?
So in this webinar, we're going to talk about multi-channel control in aerospace and defense spheres. This topic is really important and interesting because now we implement multi-channel controllers, we increase the channel numbers, and in that case, our users, our customers can increase the number of sensors they have, and of course, they can place huge objects on their shakers. And as you know, to get the best results, you need to place the main control sensor in the center of the shaker stable, but because of the fixture, you can't do this. And in that case, you need to place multiple sensors and get the data from them, and after that to calculate the control values. In that case, we have multi-channel control feature in our single shaker tests. And I think now we can go through our topics of this webinar. We're going to talk about the purpose of multi-channel control. We will describe all 3 ways of this control. We'll discuss protection features, and of course, I'll make some multi-channel control examples. So,
yes, and I would like to add some information about technical sides of our webinar tools. We have a question section where you can ask questions and let us know if anything goes wrong. And you also have a raise your hand tool to let us if anything goes wrong.
So during the engineering and testing process, we need to perform vibration tests and checks for our device under test parameters. In aerospace and defense spheres, such objects are usually represented by complicated objects with advanced structural parameters. It can be satellites, some flying objects, or some huge loads, and so on. Some parts of our device under test can be hard to damage, but others can be damaged or broken easily. And this destruction can happen on resonances and high amplitude profile regions. Basically, during the regular single shaker test run, we use only one control channel and multiple monitoring channels. And as I mentioned earlier, the best way is to place control sensor in the middle of the shaker's table and then place the object with its fixture. But sometimes we can have rather complicated objects and we won't have an ability to place the sensor the described way. But there are cases when we need to take into account data from multiple channels. For example, we have one shaker and a lone object. I'll show you this example today. And in that case, it's better to have multiple control channels on the ends and in the center. In that case, we will increase precision, get better results, and decrease risks of damage. So here you see an example of a fixture. We have 4 places for sensors in the corners here and 1 in the center. The best way is to place the center here in the center. In that case, we will get the lowest error values. But we also tested variants with the single sensor in the corner, which was used to control, this one of these points. It had the highest error value. After that, we placed 2 sensors in the corners. You see that an error decreased. And after that, we placed 4 sensors in all corners. I'll show you this example today. And that gave us place to handle our testing object, and we got the best results. So I think now we can continue with ways of control for multiple channels.
Philips, could you please answer my question? How many ways of control for multiple channels do we have in TestUp?
In TestUp, now we have 3 basic ways. It's the control by maximum, the control by minimum, and an average-based way. An average-based way can be split in 2 parts. The first one, when we enter weight coefficients for the channel as 1, that means that we will calculate an average value using this left formula, or we can set the weight coefficients for the channels. For example, we can enter the values like ones for left and right sensor when we have a beam, and a higher value, for example, 3 in the center sensor. That means that the center sensor will have more control value than the others, and in that case we will use this formula. We will get the channels data, after that multiplied by the coefficient, and in that case we will get the best results. I'll show you the correct example of using this feature using the shock test, but it will be a little bit later. Do we have any other questions?
Yes. When do we use average in multi-channel control?
I think we should use averaging using weight coefficients or without weight coefficients in a situation when we have a resonance on the fixture or the shaker's table. And I think you need to remember that by averaging the data, we don't change the amplitude values or other parameters. It only helps us to avoid the amplitude peaks on these frequencies, and we'll have a sine test example when we will avoid resonances and you'll see it better.
Thank you.
And now another important feature we have in multiple control channels is protection. In our newest version, we implemented individual limits for abort and tolerance. We can set notching limits. I'll show you also an example. It can be set as stable now. For shock tests, we implemented individual filtering options. And of course, for sine test, we have a brand new feature which is called open channels control. And it is a really interesting feature because you can continue to run your test when some of the sensors are damaged or disconnected. And of course, I think we will improve this feature. We will improve the channels number for this, and I'll show you also an example of using this feature in TestUp. And I think now we can continue with our setup.
Yeah, let me tell you about today's setup. We have our regular RLC21M controller, RLA200 amplifier, and a shaker. Also, we prepared two objects for testing, a beam and a frame. On the beam, we will have 3 sensors, and on the frame, we will have 5 sensors.
So here you see our first setup. It's a frame. Here we will place the sensors into these points. Here it is mounted on the shaker, so we don't have a sensor in the middle. And now I think we can continue in TestUp. And our first test will be sine. Let me check my profiles, and I will also enable my camera. Here you see our shaker. Let's go to TestUp. And here we need to create a new channels configuration. We have 4 accelerometers. They have IP type. I need to check the sound. It's okay. We go to configuration tab. Here we have channels. Let's add a new configuration and call it webinar 1. Here we have 4 IP sensors and their sensitivity is 10 millivolts per G. Let's press OK. And after that, we need to create a new sine test. Here. We will run from 10 Hertz up to 1000 Hertz, and our amplitude will be 5G. And also, I'll change abort limits. And after that, in schedule, we will have a run profile. And then in channels, we select our webinar 1 configuration and set all our channels as control. And we disable these checkboxes. This checkbox column means that we will check shaker limits on our control channels. On the right side, we have test limits that we will check the test limits line. And after that, as I mentioned earlier, you can set individual channel limits like lower and upper abort lines in decibels, like this. And here you see that we have control strategy based on weight coefficients, maximum and minimum. And here we have our coefficient values. Now we will control by regular average. So we can apply the settings. Now let me set up the gain on the amplifier. And let's start the test. So let me check my first sensor. And let's set 3G level. I'll test it, and after that we will run at 5G. So I think we had some issues with the cable. And I think I will change the cable on the first channel.
Well, actually, we ran the test before the webinar and everything was okay, but now something went wrong.
So I changed the cable. So I changed the cable and now everything is working.
Hooray.
So you see that we are running profile, getting the control values from all the sensors. And here we have some resonances here. You see it, I hope. But the main feature I wanted to show you in this test is open channels. Let's stop the test. After that, to enable open channels functionality, you need to go to configuration, default settings, and here we have emergency stops when we have an overrange on control and measuring channels. We disable it. And after that, we go to our settings. And here we have settings of open channels. We go here, enable this functionality, and let's set the number of open channels as 3. What does this feature mean? When we run the test, we can have our object damaged, or we need to damage it, and some of the control sensors can be damaged, disconnected, or if we have a resonance, they can get zero amplitude, and this zero data will go to the control of and averaged, and it's not correct. And in that case, we will discard this channel's data. So all sensors have a stud mounting, but sensor here, it is another type of mounting, and during the test run, I'll disable this sensor. So let's apply this feature. It is still control. And we run this test. Here you see that we are running. And now I'll take the sensor off, and we're still running. After that, let's go to test settings and, for example, change the way of control strategy. We will set minimum, and let's place the sensor back. We apply the settings and run the test again. Let me double check the settings. Oh, I see a message in the question about Murphy laws. It's true, because we double checked everything before this webinar. And I think I need to check all the cables again for all the sensors. So you see that we are running, and let's disable the fourth sensor, and we will disable the second sensor. And you see that because we disabled two sensors, we got higher amplitudes because only two channels are used for control. Let's stop the test. Put the sensors back. And now I think we can go to the next test. It will be random. Let's check our questions, and or maybe you have questions.
Yes, I have a question, Philips. Can you please explain me why do you have open channels only in sine?
We have open channels only in sine test because in sine test we get data for only one frequency. For example, in random or shock, we calculate the control values using the full spectrum. And in sine, because we have fixed frequency sine wave, we can enter some resonance frequencies, and in that case, the control data on that sensor will be rather low or will get zero values, and this situation can happen only in sine.
Okay, I got it. Thank you.
And our second test is the same frame with 4 sensors, and it will be random. Let's create a new test. We will run from 20 Hertz up to 500 Hertz. And here I want to run it at 4G amplitude value, so I use the recalculate feature. We will run this test for 90 seconds, and after that we will change the configuration, and here set all the sensors as controlled. And after that, I'll show you the notching feature. So let's turn on the gain and start the test. I think I have some issues with the first sensor. I think soon I'll need to replace it. And here you see that we are running this test with 4 control channels. The spectrum is averaging, and because of the fixture on the 4th channel, you can see that we have a peak on the spectrum, and I think something like 550 Hertz we have a resonance. And using notching, next feature, I'll change these values. I think now we can stop.
We have a question in our question box. Do you have notching at ranges?
Yeah, we implement notching at ranges, and I think I'll set it right now to show you an example. Let's go to test settings, go to limits, and here we have our notching. Let's set an upper limit for the 4th channel. We set it as limit table, and here we can enter our values. Here we will limit our 4th channel from 100 Hertz up to 300 Hertz, and we will limit it as 1G. Here we need to enter some values to ignore the error message. Here we recalculated it. Press OK. And on the 2nd channel, we will set a lower limit with table, and we will set it from 40 Hertz up to 60 Hertz. And here I enter the required value of 5.5G, because we have a profile with 4G acceleration. You'll see on the graph interesting thing. Here we have this upper limit, and I think here, yeah, here we have another limit for the fourth channel. So let's start the test. Now the system is starting up. And here you see that here on the second channel, we decreased the control values from 40 to 60 Hertz. And using notching on the fourth channel, we changed the control value here in this range. And we still have a main profile line, but we changed our control values using notching like this. And I think I can stop the test now. And now we're going to change our setup. Let me show you the picture. Here we have a beam with 3 sensors. And let's go back to TestUp. I'll stop webcam and I'll change the setup now. It will take some time.
If you have any questions, please don't hesitate to ask them in the question box.
So the last sensor is connected. I'll enable the camera. So you see a beam and sensors. For this setup, we need another configuration because the main sensor is APE 10 millivolts per G, and sensors on the ends are charge sensors with sensitivity of 10 picocoulomb per G. Go to channels. Let's add webinar 2. Here we change to charge and apply the configuration. We will switch back to sine test. Let's create a new test. We will run from 20 Hz up to 50. We will have a lower amplitude of 2G. And now we set webinar 2. And now we will run only with one control sensor. It will be the second one. And the first and the third will be only measuring. And now I'll apply the settings. Let me double check. And I think now we can start. Here we started the test. Soon you'll see an amplitude increase on the first and the third sensor. And we'll get resonances. Here you see we got a peak. And now I think we'll get a resonance on the other side. So we have two perfect peaks, and the center sensor is going right across the task line. Now let's stop the test. And here we will switch these channels to control. And after that, I will change the weight coefficients. I know that the channel in the center has the best value, so I set its value higher than the others. After that, I start the test again. You see that the values are higher than this, but our control value is going across the control line, and as I think we will get lower peaks, and changing the values of coefficients, we can decrease their sharpness. So the peak is lower now. We still have a resonance, but its peak amplitude is lower. And I think using this feature, you can try to avoid really high and sharp peaks. So let's stop the test and increase this value more. So weight coefficient is really nice feature. I always use it when I have to run tests with multi-channel control, and sometimes it can help you to start the test, which you can't start using the maximum or the minimum control values. Let me scale it a bit. So changing these parameters, you can get different results and find the best settings for your setup. And now we go to our final test. It will be shock. We will run regular shock. Here we will set our peak amplitude as 4G. We will perform 100 shocks. And here in the channels, we change our channels configuration, disable the fourth channel, and set our IP sensor as a control one. After that, as I mentioned, in this feature, you have independent filters for the channels. For measuring, it will be applied and used only for data visualization, but for control channels, data will be filtered and used for control. So let's start the test, and after that, we will find the best filtering features options. So let's start the test. You see that using middle sensor we go right through the task, but on the ends we have noisy signal. It has a strange waveform. Let's open spectrum. Here you see that here we have some normal spectrum from 30 up to 200 or 300 hertz. And I think now let me show you the filtering option. Let's stop it. Go to test settings. Here I'll set from 100 hertz up to 500 hertz. And here to show you, I'll enter 50 and 70 hertz. And here we'll see the spectrum from for example, 200 Hertz up to 300 Hertz. And let's start the test again. So you see that our spectrums are filtered. You see only the desired frequencies. Let's wait for startup.
Philips, I have a question. Could you please explain how do you average shocks?
Using averaging in shocks, we take the filtered data which is averaged by their weight coefficients, and all is done in frequency domain. I think that's the best explanation I can give, but if you want to get more information, let me think a bit.
Okay, thank you.
So you see that because of the filter on the control channel and doesn't have a wide frequency range, the startup may take a long time. So let's stop it and disable the filter on the control. And also we will run this test with 3 control channels. And now their weight coefficients are equal. I know that in that case we'll get or an emergency stop or startup failed, and after that I'll show you how to fix it. That will happen because of the data from the third and the first channel. So you see the second channel has some strange values here. Its waveform has some peaks here. And in that case, to fix it, let's stop the test. We will change its weight coefficient. Here we set it as 3. And that means that the data from the second channel is more important for our control process. So here you see we had a quick startup and we are running the test. But you see, because of the control using 3 channels, we have changed our waveform, but in that case, if you don't have an ability to place a sensor in the middle, you can use these features to get better results. Right. So I think that's all for the tests now, and I think we can make a conclusion about this topic, which I find really interesting and important. So we talked about multi-channel control in single shaker vibration tests. We discussed ways of multi-channel control, discuss protection features, their usage, something like notching, open channels, filtering, and of course, we made a live example of using multi-channel control feature while running sine, random, and of course shock vibration tests. And I think
yes, the webinar was really interesting, and we got one more question from you. So, Philips, do we have multi-channel control for loops in multi-shaker tests?
that's a great question. I think we'll try and develop it in one of the upcoming versions, but it will take a lot of time because all the control algorithms must be changed. It must be tested because, as you know, multi-shaker tests are really complicated thing, and in that case, we need to check that all our safety parameters and control features are working exactly as we expect, because we don't want to damage our customers' equipment. And in that case, it must be tested. But I think maybe at the end of this year or next year, we'll get this feature because it takes a lot of time to develop. And thank you for joining this webinar. Have great holidays.
Thank you for being with us today. And if you have any questions, please send them to our emails, which you can see on the screen.